Hello everybody. Today is the fourth lecture of solid state physics. So today's topic is the relation between number density and mass density and then the Miller indices. So first you can see the relation between number density and mass density. So for density, how I have taken a notation of rho, which is looking like this. So rho is standing for density. So I am taking number density as rho suffix n, which is equal to n by v. N is here number of atoms in the unit cell, and v is the volume of the unit cell. And rho suffix m is the mass density. So rho is density suffix n because it's number density, n for number, and rho suffix m for mass, so it is mass density. Easy to remember. Now, okay, number density means it is number of atoms per unit volume. So the unit can be some number of atoms per unit centimeter cube or per unit meter cube, that is centimeter to the power minus 3 or meter to the power minus 3 for rho n. Now for rho m as it is some mass density, so it will be some mass unit by some volume unit. So it will be gram into centimeter to the power minus 3, or in SI unit kg into meter to the power minus 3. So this is the unit. You can also call like kg per meter cube, gram per centimeter cube. You can also call it like that. I like to call it in this minus to the power minus form than by something like kg per meter cube, but I like to tell like kg into meter to the power minus 3. It is more convenient for me, that's why I'm using it, but there is no restriction, you can use both. Okay, now this is a very important formula. This is the number density and mass density and how they are related. So you can relate it from here, like rho n is the number of atoms per unit volume, and this is the mass. So mass of atom, or what you have, the total thing, mass per unit volume. So if we replace volume thing by anything, like I can replace in this equation the volume thing, then I will get a relation. And now this is the same relation which I will get by this, so you can do it by yourself. It is very easy. And here number of atoms per unit cell, I am taking it like 1 mole. So if it will be for 1 mole, then number of atoms in 1 mole will be the Avogadro number, which has the value of 6.023 10 to the power 23. If the mass density is defined in gram, that is the rho n will be in centimeter to the power minus 3, or Avogadro number will be 6.023 into 10 to the power 26 if the mass density is defined in kg, that is rho n will be in meter to the power minus 3. So there is no problem, you can use it how it will apply in the problem. So this is very important, just remember this formula. It is important in it will come in the exam, like in many form where you have to calculate these things or you have to relate these things. And ma is the atomic mass in the unit of AMU. Atomic mass means like we are taking standard as carbon, so atomic mass of carbon is 12, you know. So now there is another important relation. So if we take it for cubic crystal, you can see here for cubic crystal the sides are equal, like A is equal to B is equal to C. So the total volume of a unit cell in cubic will be A cube, which is like A cube. So if I put this A cube here at row n. So row n will be n by a cube. Now if I put it here, then what will be? Then just put it, you do it in your notebook. So if I put this, I will get V equal to, or a cube equal to n, which is the number of atoms in the unit cell, into Ma, atomic mass, by this Ma is the atomic mass, by Na means Avogadro number, into rho m. Rho m means mass density. This will be a cube or volume. So A will be cube root of that, or this to the power 1 by 3. Now number of atoms in unit cell, what will be? I have explained it in the last lecture, like lecture number 3 in solid state physics. You can check it. So for simple cubic, the number of effective atoms in one unit cell is 1. For BCC it will be 2, and for FCC it will be 4. Okay, this is the thing. This equation is also very much important. Mark it, highlight it, and remember it. So next, our next topic is very much important, which is Miller indices. Miller indices are used to determine the orientation of planes in the crystal. So this is represented by HKL in the first bracket. So there is different meaning of the bracket, like first bracket, second bracket, third bracket, all have different meaning. So whenever you will use Miller indices, you have to use the first bracket only, otherwise it will be wrong. I will tell about the meaning of second and third bracket later. So here you have to write the HKL without any comma or any full stop, anything. This is just write like this. Like the Miller indices, whatever we will find, this will only valid for some crystal structure which has some special characteristics. Like this is only valid for this crystal structure which have alpha is equal to beta is equal to gamma is equal to 90 degree. So this is not applicable to all, because I have just explained in the last class that every crystal structure does not have this alpha beta gamma same, or it is not equal to 90 degree. So this Miller indices, whatever we will do after that, these all the things will applicable for only if the crystal system is having the condition is alpha is equal to beta is equal to gamma is equal to 90 degree. So which crystal structure have this condition? This is cubic, tetragonal, and orthorhombic only, nothing else. But in our case, we will just in your exam or everything just and this is only we are dealing with cubic for simplicity. But in interviews and all, they can ask you, because these are some topics in like IITs, and like in my coursework I have faced a question. I have given some Miller indices and all. I have to draw the thing, and then I have to um, find which crystal system it is. So I can find only this cubic, tetragonal, orthorhombic. So if you are finding other other crystal system, and if you have, like, it will be in my case it was orthorhombic, because all others they does not have the alpha is equal to beta is equal to gamma is equal to 90 degree. So in this way you can understand, and this will not relate in your this will not be asked in your NET or GATE directly, but it can be a good question for the interview. Here are some common Miller indices which we should know, because these things is a basic thing and sometimes it comes in the exam. So first one is 100, then 110, then 111, and then this should be -100, but it should be one bar 00. But as in the word I'm not finding the tool to write the thing, so I'm writing it as -100. So just remember this you should not write like this, you should write 1 bar 0 0. And similarly this is -1 0, means you have to write it like 1 bar 0, and then it's 2 0 0. So we will draw all these planes. Then there is another term which is called family of planes. This is the notation for the family of planes. Okay, this is HKL I have written. So it can be like 1 0 0. So 1 0 0 means 0 0. So it will be 1 0 0 0 1 0 0 0 1, and also the minus things like 1 bar 0 0 0 1 bar 0 0 0 1 bar. You please write it in your notebook. If it is like 1 1 1, then what will be? Then it will be, there will be total 8. So I have written is all -1, but you have to write it 1 bar. Next is a third bracket. So third bracket means, it means the direction indices. This is the first example of drawing of Miller indices. So this is for 100 plane. So when this is given, means Miller indices is given and you have to draw the plane. First take the reciprocal of the Miller indices, that is 100. The reciprocal will be 1 by 1 means 1, 1 by 0 means infinite and infinite. So it will be 1, infinite and infinite. So the plane will cut x-axis with 1 or unit of A, and it will not intersect the axis y and axis z. So it will be parallel to axis y and axis z. Or you can do like this, what I have written here: h proportional to k proportional to l is equals to a by OA proportional to b by OB proportional to c by OC. So OA is the intersect along x-axis, OB and OC are intersects along y-axis and z-axis respectively. So we have got here OA is equals to A, or if we take it as 1, so it will be 1, and then OB and OC will be infinite. So the Miller indices will look like the green color plane. Next it is 100 plane, means we have to take the reciprocal, means it will be 1 1 infinite. So it will cut x-axis and y-axis at A and B, but it will not intersect with z-axis. So this plane will look like that, the orange color. The previous plane had a square shape, but this plane has rectangular shape. Next is 1 1 1 plane. So the reciprocal will be 1 1 1 itself. So it will cut x-axis, y-axis and z-axis at A, B and C, or 1 1 1. So the plane will look like that. Orange color is indicated by this. This is 1 bar 0 plane. So it will be, if we take the reciprocal, then it will be -1, infinite and infinite. So it will cut x plane, or it will cut x-axis at -A. Now if we move the origin to point O, then it will be in the negative axis of x. So the plane is indicated by the green color here. So you can see 1 bar 0 plane is parallel with 100 plane, or these are similar. Similarly, you can draw 1 bar 0. This is similar as 100 plane. Next, this is the 200 plane. So 200 plane means if we take the reciprocal, it will be 1 by 2 infinite and infinite, or A by 2 infinite and infinite. So A by 2 means the plane will cut the x-axis at A by 2. So the plane will be in between the cube. So you can understand it is similar with 100 and 1 bar 0 0, but it will be in between.